What I'm going to be doing is basically outlining the arguments that the British idealist philosopher F.H. Bradley gives for the unreality of space and time. So I'm just going to jump right into it. As the 19th century faded into the 20th, the rich atmosphere of British idealism, which had been saturating the Anglo-American philosophical landscape for over 50 years, grew faint and evaporated into memory. At the movement's zenith, F.H. Bradley played the part of Father Parmenides in the minds of the defenders of idealistic absolutism. Bradley was even crowned the Zeno of modern philosophy for his dialectical prowess, ingenious perspicacity, and notorious metaphysical views, such as his denial of the reality of space and time. Before diving into the details of Bradley's treatment of space and time, it is necessary that we take a step back and survey the axis about which the entirety of his metaphysical system orbits. For Bradley, metaphysics is an attempt to know reality as against mere appearance, or the effort to comprehend the universe, not simply piecemeal, or by fragments, but somehow as a whole. The aim of metaphysics is to arrive at a Weltanschauung that satisfies the intellect's demands. In constructing a metaphysics, it is only that which thought is compulsory and irresistible, only that which thought must assert in attempting to deny it, that is a valid form of metaphysical truth, or valid foundation for metaphysical truth, rather. The proposition, ultimate reality does not contradict itself, is such an example. Indeed, this fundamental criterion underlies all metaphysical inquiry. For either in endeavoring to deny it, or even attempting to doubt it, we tacitly assume its validity. Bradley calls ultimate reality, this non-contradictory goal of thought, the absolute. The absolute cannot be determined by anything external to itself, and it must embrace all diversity and all appearances within itself in a harmonious form. In other words, the absolute must exhibit 1. All-embracing inclusivity, 2. Concrete self-dependence, and 3. Individuality. A question then arises. Are space and time self-consistent, self-dependent, and all-inclusive individuals? In answer to this question, Bradley replies in the negative, and he rests his case on a battery of arguments. His chief arguments against the reality of space and time are to be found in chapters 4 and chapters 28 of Appearance and Reality. To say true to Bradley's original arguments, it is best that each be presented in full, so that we can uncover why he thinks that space and time are appearances, and see how space and time fail to live up to the ideal of self-consistency, self-dependence, and all-embracing inclusivity. Okay, part 1, the unreality of space. Bradley prefaces his argument by telling us that when we concentrate on space or extension, simply as it is, we shall find that space's continuity and discreteness give rise to irresolvable difficulties. Bradley proceeds to illustrate space's inconsistency in a form which exhibits most plainly the root of the contradiction, and also its insolubility. We are presented with an antinomy. 1. Space is and yet cannot be a relation. And 2. Space is and yet cannot be a quality or substance. Bradley defends the antinomy's thesis as follows. Quote, space is not a mere relation, for any space must consist of extended parts, and these parts clearly are spaces, so that even if we could take our space as a collection, it would be a collection of solids. The relation that would join spaces would not be mere relations, and hence the collection, if taken as a mere interrelation, would not be space. We should be brought to the position that space is nothing but a relation of spaces, and this proposition contradicts itself. Again, from the other side, if space is taken as a whole, it is evidently more than a relation. It is a thing or substance or quality, call it what you please, which is clearly as solid as the parts which it unites, end quote. In order to understand this stage of Bradley's argument, let's examine the space which we take ourselves to be situated in. We regard this spatial order to be a whole that is differentiated into a multiplicity of parts, each part of space being a three-dimensional region that internally differentiates itself into smaller three-dimensional regions, i.e., into smaller parts of space. Furthermore, every part of space presents itself to us as a quantitative magnitude capable of extensional measure. For example, you could measure it with a yardstick or a ruler or what have you. Thus, space is an order of parts intraparts and parts extraparts, so parts inside one another and parts outside of one another. Now, if we examine two disjoint regions of space, so for example, two non-overlapping and non-adjacent parts of space, for example, this one over here, A, and this other one over here, B, we find that A and B are incompenetrable. They exclude each other from their respective domains in the same way that the two like poles of two magnets repel each other. However, since A and B are disjoint regions of space, they do not have any shared constituents or components. What is it then that grounds their mutual exclusion and repulsion and serves to couple them apart? It is the spatial expanse, X, so we have A over here, B over here, then we have X in between them, this intervening space between the two. Like a pseudopodium that pours its own substance out of itself, X simultaneously pushes A and B apart by uniformly diffusing its own inner volume of intangible, ponable filling of sorts, thus spreading itself out in all directions. In doing so, it solidifies itself into a sturdy block of space that shares an outermost boundary with A being over here, and another with B, securing their respective identities as disjoint parts of space. Additionally, X has a quantitatively determinable bigness or muchness about it, or voluminousness. Despite there being no body, i.e. a somewhat, that is more than merely spatial, pervading the stretch of space in question, there being nothing save this insubstantial solid block of space itself, we are compelled to treat the spatial fissure between A and B as a somewhat with a magnitude of its own. A puzzle emerges. What is this intervening space? This is where the thesis of Bradley's antinomy enters the scene. Bradley argues that the part of space separating A and B cannot consist of mere relations. On the contrary, every spatial region has parts, whereas relations have terms, and it is senseless to speak of a relation as having parts. Furthermore, it is meaningless to say that a relation is extended or that it has volume or bigness. These predicates are meaningful only when they are attributed to the terms of a relation, not to the relation itself. Therefore, we are forced to conclude that these relations are not themselves extended. But, if so, what accounts for the extended or voluminous character of different parts of space, and the spatial order as a whole? Bradley thinks that this is impossible. It is impossible for space's extension or volume to consist of a mere interrelation of unextended terms. For example, relations between relations or relations between points. Because, quote, if the parts of space are not spaces, the whole is not space. Now, one cannot object to Bradley here on the ground that he is, quote, expressing the old and familiar worry about how extended space can be made up of extensionless parts, end quote. If this were the basis of Bradley's argument for why space cannot be a relation, or a mere relation rather, then it could be dismissed as resting upon a misapplication of arithmetical summation, i.e., mistaking the arithmetical summation of the lengths of an infinite number of degenerate intervals, i.e., subintervals of a zero length, for a well-defined procedure. You can't really say, like, okay, you're adding up unextended points. You can't get a line out of that. It's just not a well-defined procedure, even though intuitively we might think that, oh yeah, sure, you would just add up the number of points in a line and then you'd get the actual length of the line. But you're not allowed to do that just because it's not defined, really. Okay, so this stage of Bradley's argument is further clarified by W.J. Mander in his book, An Introduction to Bradley's Metaphysics. But I'm not going to read this long quote here. I'm just going to be pointing out another issue that Bradley would have pointed out. He would have pointed out a vicious circle involved in the attempt to account for the spatial metric, or the capacity to measure space in a way that has like an actual determinate bigness about it. So a series or an infinite series of points, just bare points, it gives you mere order. It doesn't give you distance relations, really. So if you say, like, space is infinitely divisible right, or is continuous rather, and is infinitely divisible, and the terms of the relations are just mere points, you can't get any kind of quantitative character out of that. You can't tell, like, okay, how far is it from this point to this point, or from this point to this point? In a mere, essentially the technical term is, it is metrically amorphous. So I'm just going to go on. Bradley would have said that the procedure of trying to introduce a metric into this, this metrically amorphous space would have involved a vicious circle, but I'm not going to go into that. I'm just going to move on. So the antinomies antithesis, we're going to be talking about that now. Quote, space is nothing but a relation. Take then in a space any parts. These parts, it is assumed, must be solid, but they are obviously extended. If extended, however, they will themselves consist of parts, and these again of further parts, and so on without end. A space or a part of space that really means to be a solid is a self-contradiction. Anything extended is a collection, a relation of extendeds, which again are relations of extendeds, and so on indefinitely. Space is essentially a relation of what vanishes into relations which seek in vain for their terms. It is lengths of nothing we can find, end quote. We saw before that the metrical character of space forces us to treat every part of space as a solid unit that does not admit to being reduced to mere relations of joining. However, when we turn our attention to any part of space, its extendedness runs into conflict with the attempt to take it as a solid, self-standing unit. Far from being irreducible to mere relations, every extended part of space passes away into nothing but relations. Every part of space envelops within itself nothing other than an extended part of space of lesser voluminousness, in relations of joining, which in turn dissolve into extended parts of space of even lesser voluminousness, in relations of joining, and so on, and ad infinitum. But where are the fundamental terms of these relations? The terms, writes Bradley, are essential to the relation, and the terms do not exist. Searching without end, we never find anything more than relations, and we see that we cannot. Indeed, none of the relations could ever be instantiated unless there were terms there to be related. However, each level of relations presupposes a lower level of relations on which it depends. There is no non-relational bedrock to be found. The antinomies thesis compels us to treat space as a system of relations holding between terms possessing extension. For if space was reduced to relations between unextended terms, then the spatial order would be metrically amorphous, a result that necessitates the existence of something extrinsic to the mere spatial order in order to supply it with a determinate metric. But this supplementation not only involves a vicious circle, but also entails that the spatial order as such lacks any kind of self-containedness or self-dependency in the way in which we would normally take it to be. The antithesis, by contrast, forces us to treat these extended terms as infinitely divisible, resulting in the spatial order internally disintegrating itself into an endless collection of relations that seek in vain for their self-standing relata. Thus, Bradley concludes that space is an unreal appearance. And so, since I only have roughly 7 minutes left, I'm just going to be breezing over the unreality of time arguments. Okay, so after demonstrating to his own intellectual satisfaction space's unreality, Bradley moves on to the question of time's reality. So I'm going to quote him real quick here. Time is a relation, and on the other side, it's not a relation, and it is, again, incapable of being anything beyond a relation. If you take time as a relation between units without duration, then the whole of time has no duration, and is not time at all. But if you give duration to the whole time, then at once the units are found to possess it, and they thus cease to be units. Time, in fact, is before and after in one, and without this diversity, it is not time. But these differences cannot be asserted of the unity. And on the other hand, and failing that, time is helplessly dissolved. So now we clearly see that there's a parallelism here between Bradley's antinomy of space and the one that he just outlined. So we can better illustrate this if we think of time as consisting of terms linearly arranged side by side in relations of before and after. These terms either have duration or they have not. If they have duration, they are seen at once to be infinitely divisible. However, if they are infinitely divisible, they fail to be self-standing solid units. On the contrary, they vanish away into mere systems of before and after relations. We are never met with a bedrock of non-relational standalone terms. As Bradley says, the pieces of duration, each containing a before and after, are divided against themselves and become mere relations of the illusory. If the terms of temporal relations possess duration, they reveal themselves to be nothing other but their own relation to something beyond themselves, and this something proves not discoverable. On the other hand, if the terms are durationless, then an event's duration, and the duration of the time as a whole, must be a mere ordered series of durationless terms before and after in relation to each other. And this seems not possible. Time consisting of discrete atomic lapseless units gives rise to even more complications. Every object would be frozen in place at every moment. In other words, there would never be a time when an object is traveling from here to there. It would simply be here at one instant and there at another. And when we try to discover that diverse velocities and different rates of change within a single period of time would then become impossible, the consequences seem even more dire. So I'm going to be skipping through another argument that he gives for the unreality of time, since it's kind of almost supererogatory in his own eyes. So I'm going to be moving on to the conclusion. Bradley's arguments for the unreality of space and time prompt us to reflect upon whether these phenomena can provide us with an intellectually satisfactory account of the real. On the one hand, we find space to be and not to be a mere relation. On the other hand, we also find it to be and not to be a quality or substance. And again, with time, we find that it must be and yet cannot be made of pieces. Neither space nor time proves free from self-discrepancy. Neither are self-contained nor self-dependent phenomena. And their failure to satisfy these conditions necessitates their unreality. Space and time, therefore, are appearances. Space and time cry out for remedy, and this they find only in the arms of the absolute. Thank you.